If you want to learn cybersecurity, you face an immediate problem. You need to run professional, highly invasive network tools, but you have to do it without accidentally breaking the computer you use for everyday life. Let's clear up the movie stereotypes right now. The goal of an ethical hacker is never to recklessly wipe a hard drive. The actual goal is to build a safe, fully functional, sandboxed laboratory where you can test vulnerabilities without collateral damage. To understand how to build that lab, look at this comparison matrix of the three major operating systems: Windows, macOS, and Linux. We are evaluating them based on their global usage, whether they are open source, and the security tools they run natively. Windows and macOS dominate the global usage column. Because almost every corporate office and personal user relies on them, they make up the largest attack surface in the world. Most malware is specifically engineered to target these two systems. Linux serves a completely different purpose. Because it is open source, anyone can view and modify its underlying code. This gives you deep, unrestricted control over the hardware, effectively turning the operating system into a specialized toolkit. macOS occupies a middle ground. It is built on Unix, which makes its terminal environment quite similar to Linux. But because it requires expensive Apple hardware and keeps its core code heavily locked down, it is far less practical as a primary testing platform. That leaves Linux. Almost every professional penetration tester uses it natively because industry standard tools like Nmap for network scanning or Metasploit for exploitation are designed specifically for the Linux architecture. This creates your central dilemma. To be effective, you have to deeply understand how your target behaves, which is usually Windows, while operating entirely from a specialized Linux toolkit. Mastering cybersecurity means adopting a dual ecosystem approach. You are required to intimately know the flaws of an operating system you don't even use to run your attacks. Once you decide to use Linux, you hit the next wall, choosing a distribution. There are hundreds of versions of Linux available. The right choice comes down entirely to matching the software's demands with your specific hardware and your learning goals. Kali Linux is the industry standard. Developed by Offensive Security, it comes preloaded with over 600 specialized tools out of the box. As this graphic illustrates, it operates like a massive digital Swiss Army knife, with blades ready for everything from packet analysis to exploitation. But Kali comes with a strict trade-off. Running 600 tools takes a significant toll on system resources, meaning it can struggle on older hardware. For a beginner, having hundreds of highly complex applications visible on day one often leads to immediate overwhelm. If your computer lacks a massive amount of processing power, your primary alternative is Parrot OS. Parrot OS is deliberately engineered to be highly efficient. It requires far less memory, preserves laptop battery life, and runs smoothly on older, budget processors, while still providing the core security tools you need. The trade-off with Parrot is the community size. Kali has been around longer, so if you encounter the strange error code, finding a quick forum fix for Kali is much easier than it is for Parrot OS. Then there is Tails OS. This distribution shifts the focus away from active network testing and entirely toward privacy. Tails routes all of your internet traffic directly through the Tor network. It is designed to run entirely from your computer's temporary memory, meaning the exact moment you shut it down, it leaves absolutely zero trace on the host machine. There is no objective best Linux distribution.
The correct choice is simply the one that scales to your laptop's hardware limits and matches your specific threat model. Choosing the software is only half the battle. The next, and arguably highest risk hurdle, is deciding exactly how you will run that software without overwriting your main hard drive. Look at this deployment flowchart. Your path depends entirely on your hardware capability. The first method we have to evaluate is dual booting, which means installing Linux onto the exact same hard drive as your existing Windows setup. By dual booting, you give Linux direct access to the metal. It unlocks 100% of your raw CPU and RAM, which is mandatory if you are running highly intensive tasks like cracking complex password hashes. The cost is severe friction. Dual booting carries the risk of accidentally overwriting your primary bootloader during setup. Plus, you have to completely restart your computer every single time you want to switch back to Windows to check an email. If you follow the high RAM CPU branch on the left, you reach the virtual machine path. A virtual machine creates a computer within a computer. It is a completely contained, risk-free environment. If you accidentally delete a critical system file in your Linux lab, you just delete the virtual machine and spin up a fresh one in seconds. The limitation of a VM is that it splits your hardware in half. You are running 2 operating systems simultaneously, which means your host computer realistically needs a minimum of 8 GB of RAM to avoid freezing. If your hardware cannot handle that, you follow the branch on the right, the live USB. A live USB bypasses your internal hard drive entirely. You install the operating system onto a portable flash drive and boot directly from it. It maximizes speed on older processors and leaves your primary hard drive untouched. How you deploy the system dictates the safety of your daily driver laptop. For anyone learning the ropes, relying on contained virtual sandboxes or portable USB drives is always the smartest move. Let's turn all of this theory into a concrete plan. It's time to map out the final recommendations so you know exactly which file to download today. This quadrant chart maps out your exact ideal setup. The horizontal axis measures your hardware power from low to high. The vertical axis measures your technical skill and your willingness to risk system stability. We will start in the high-power, low-risk quadrant. This is what we call the 80% rule, because it applies to the vast majority of standard beginners with modern laptops. For the 80%, the recommendation is simple. Keep Windows or macOS as your daily system, and install Kali Linux inside a virtual machine. This gives you total safety and immediate access to the industry-standard toolkit. Next is the low-power, low-risk quadrant. If you are working on an older machine, this is the zone for the budget learner. Budget setups should avoid the heavy lag of virtual machines. Instead, grab a cheap flash drive and run Parrot OS as a live USB. You get lightning-fast performance without asking your CPU to do double duty. Finally, we have the specialized zone for the privacy operator. If your primary concern is strict anonymity rather than running exploitation tools, you bypass Kali and Parrot entirely. Flash Tails OS onto a USB drive for frictionless, untraceable web browsing. At the end of the day, an operating system is just a tool belt. Spending weeks agonizing over which one to use is a trap that prevents you from doing the actual work. By matching the safest, most friction-free setup to the hardware you already own, you bypass the choice paralysis. Your lab is built, your primary computer is safe, and you are finally ready to start mastering the tool.